Yeah, thanks for that introduction. Welcome, everybody. Yeah, I'm Michael Lord, Head of Research at Beyond Zero Emissions. If you don't know who Beyond Zero Emissions is, most of you will. We're a charity and a think tank, and we're just trying to show that eliminating greenhouse gas emissions really isn't that hard. And we do that with research which focuses on the technology and shows that we already have technology available in all sectors to eliminate greenhouse gas emissions. So we've actually gone through most of the sectors, and now we're on to industry. The first report, as Rob said, from that area of work was on cement, because cement alone is a massive source of emissions. And now we're looking at everything else, the emissions from everything else that that we manufacture. The clicker isn't working at the moment. It's making a fortunate sound. Dimitri's going to look into that. So what I'm going to talk about today is I'm going to be talking about the report that we launched a few weeks ago called Electrifying Industry. And I want to get across three things. One, that there already is quite a lot of economic and political pressure on manufacturers to change the way they manufacture things and eliminate the greenhouse gas emissions. Two, that Australia is in a unique position to lead this transition in manufacturing, largely because not many countries around the world, if any, have the potential to generate renewable energy as Australia does. There's an unparalleled potential to generate electricity from solar and wind. And then lastly, how Australian manufacturers can use that renewable energy potential to make things in a different way and make zero emissions products. Oh, we're advancing. Yep. It's working. Great. So just to be clear what we're talking about in this report, we're talking really about industrial heat processes. So these are the processes that occur within a factory that require heat. So if you look at pretty much any industrial material in this room, we've got metal and textiles and rubber and glass, concrete, maybe brick. They all require heat in the manufacture. And we can have as many solar panels and wind turbines as we like, and we're still going to be producing the emissions from within the factory to generate all this heat. So how are we going to stop doing that? That's a question we're answering in this report. And we also look at some processes that use fossil fuels as a feedstock, so a chemical input into the manufacture of some important materials. So the amazing thing is when you electrify, you can actually stop using fossil fuels as a feedstock in some of these things, including, importantly, steel, which is steel manufacturing alone is 6 to 7% of global emissions. So as I said, there's quite a few reasons, developing reasons that manufacturers will transition to zero carbon, zero emissions manufacturing. And in Australia, one of those reasons, one of the pressures on them is high energy costs. So Australia was traditionally a country of low energy costs, and some energy intensive industry moved to Australia to take advantage of low costs of gas and electricity. That's not the case now. These are figures from thought that was going to be a little red light, but it's not, doesn't matter. But these are figures from 2008 to 2018. So over 10 years, the wholesale price of gas has gone from $3, even $2 per gigajoule to 8 or 9 now. And that's, people probably know, do people know why that is? Unstranded the assets. We're exporting. Yeah. Exporting oils, yeah. So now the cost of gas is linked to world prices, and that's not going to change. The prices are expected to stay high. So Australian manufacturers pay a high price of gas. Well, they pay the world price rather than a low price, and the same has happened in electricity. So for electricity prices have nearly doubled over 10 years. In the early part of that 10 years, that was largely due to increasing network costs. More recently, it's to do with the wholesale costs. And this underplays actually what has happened to the bills of many manufacturers because they were on long-term contracts. For many of them, their electricity bill, like their gas bill, has doubled or even trebled overnight. So Australia is no longer a country of low energy prices, and manufacturers here are suffering because of that. And they're suffering even more because Australian manufacturing is inefficient. So developed countries, Australia uses more energy for every dollar of output than any other developed country. And unlike nearly every other developed country, that situation of inefficiency has been getting worse in the last few years rather than better. And then we've got no plan for the emissions that come from these industrial heat processes, and they're quite significant. They're about 8% of Australia's emissions. That's the same as all cars on the road in Australia, and globally the figure's higher. It's about 12% of global emissions. And there's no plan at the moment for these emissions. Even in states like Victoria with a legislated zero emissions target by 2050, and most Australians now live in a state or territory with at least a policy to get to zero emissions by mid-century, but there's very little policy around these emissions. And we need to start now because manufacturing processes need to change. So what's the plan to eliminate these emissions? There isn't one. We're trying to develop one. And it's becoming increasingly risky for Australia as a country and for businesses to have no plan for these emissions. There's a number of global pressures on manufacturers. So one is the fact that other countries who also have zero emissions target are developing carbon policy, and they're imposing costs on manufacturers' emissions. So they're doing that in lots of ways, but the typical way is an emissions trading scheme. The EU has had an emissions trading scheme for a long time, European Union. That was a weak mechanism for quite a long time, but it's now really starting to bite and impose costs on European manufacturers. Not everyone knows that the largest emissions trading scheme in the world is now China's scheme, and they plan for that to extend progressively to more and more manufacturers. So China's often held up in Australia as sort of the real kind of climate criminal, and we'll do something when China does. And it is an energy-intensive country and an emissions-intensive country, but at least they have some policy and they have some plans to change that. So in our opinion, Australia can't be an outlier, can't have no policy in this area forever, because economies like the European Union and China are not going to put up with it forever. And we're already beginning to see soundings to this effect. So there's a trade agreement on the table at the moment between the European Union and Australia, and the European Union has said we may not sign this agreement unless you have some credible climate policy and impose costs on your manufacturers the way we're doing that. And the head of the Australian industry group has picked up on this recently and has called Australia a free rider, and has said now's not the time to test the international community's tolerance for a free rider. So Australia will at some point have to develop some carbon policy and impose costs on Australian manufacturers of producing carbon. The other kind of national and global pressure that will come to bear on manufacturers is from the investment community. So I've got a few quotes up here. This is from APRA, saying the transition to a low carbon economy is underway and the risks are unavoidable. So lots of national international financial bodies have said this risk of a carbon price coming imposes risk on the economy and on individual manufacturers who choose to ignore it. Lots of international institutions have said things like this, too dark. The transition to a low carbon economy presents a systemic risk to the global economy through a collapse in the value of carbon intensive assets. And investors representing really significant sums of money, like this group called the Investor Agenda that represent $28 trillion in assets, are saying they're urging governments to expand and increase and accelerate their climate action. And at the same time, they're really scrutinizing the corporations that they invest in. And some investors have rung me for more information about this and saying, what is your strategy for dealing with a carbon constrained environment? We know carbon policy is coming for various reasons. What's your strategy for dealing with it? And if you haven't got one, maybe we won't invest in you. And we've already seen that in the fossil fuel sector. I think there's something like $6 trillion has been divested away from the fossil fuel sector. And to their credit, many large corporations know which way the wind is blowing. I don't know if any of you have heard of the Science-Based Targets Initiative. Has anyone heard of it? Not many people. So about 500 global corporations have signed up to pretty ambitious emissions reductions target, certainly more ambitious than the average country in the world, which is one thing that gives me reason for optimism in this area. So this is just a handful of those 500 and their targets, and you'll see they are fairly ambitious, and a couple of them there, Mars and Unilever, plan to reduce their emissions by 100%, eliminate emissions, not that far away. And for what we're talking about manufacturing, what's interesting about this is that they're not just looking at their own emissions. So if you look at IKEA, you might think, well, what do? They just heat and light some shops. They're also looking at their supply chain. So IKEA has a goal that the average embodied emissions in an IKEA product must be reduced by 70% by 2030. So that affects a lot more than IKEA shops. That affects the hundreds, probably thousands of manufacturers who supply IKEA, and they're going to have to change the way they manufacture things. So how are they going to do that? Our report looks at one way of doing it, and now there are other ways. So we're talking about renewable heat, essentially, and everyone will know Beyond Zero Emissions is actually quite associated with concentrated solar. In some instances that would be a great way of getting particularly lower levels of heat, below about 200 degrees. There's bioenergy and a couple of other ways. But we wrote this report because nobody seemed to be looking in detail at the only way of getting renewable heat that can cover any type of industrial process, no matter what the temperature or how complex the process, which is electrifying. A few people, eminent names, had said one of the answers to climate change is electrify everything. So the ex-chief scientist Alan Finkel was doing the rounds a few years ago saying, let's have an electric planet and electrify buildings, electrify transport, electrify industry. But the trouble is that with respect to Alan Finkel and others, nobody was really saying how you electrify industry. It's quite easy to say now how you might electrify a building or transport. But how do you electrify the manufacture of the thousands of products that we rely on? There was really not much out there on this. So before we come to how you actually do that, we need to tackle the questions of how are we going to get all this new electricity? If we're replacing gas and coal in manufacturing with electricity, how are we going to do it? Well, what we knew right from the outset was that we've got enough electricity in Australia, or the potential to generate enough renewable electricity. Our report, this is from our 2015 report, Renewable Energy Superpower, which quantified how much solar and wind we could generate in Australia. And this is limited just to the bit of Australia within 10 kilometres of an existing transmission line. So we've got a map in the report. It's a tiny little bit of Australia. And you could generate more solar and wind from that area than all of the economically recoverable fossil fuels plus uranium, and certainly more than all the fossil fuels we could ever burn to have a hope of staying within 2 degrees. So that's an effectively limitless amount of energy. 5,000 exajoules. Well, 1 exajoule is about all the electricity we use in Australia in a year. So, 5,000 is a lot. And not one of the important points is not many countries are in this position. A lot of countries will actually struggle to replace their existing use of electricity with renewables. Australia's got the land, the sun, the wind. Repeat indefinitely, yeah. So on top of these natural resources, what's happened actually since we produced that report is that the economics has changed significantly, and people in the room will know this, but this graph spells it out pretty well. This is pretty much the levelized cost of solar and wind, both coming down steeply, and this is the national electricity market spot price. So you'll notice those prices have crossed recently, and the price is only going to get lower. We have price projections in the report. We'll probably be wrong. Most price projections are wrong, but I think we can be almost 100% confident that the price of solar and wind is going to continue to come down and significantly in just 10 years' time. So companies, the smart companies, have noticed that these lines have crossed and that renewable electricity is now cheaper than the spot price, and they're either putting solar panels up, building their own kind of significant renewable capacity, or perhaps more often signing renewable energy power purchase agreements. But we've got a whole page in our report listing lots of Australian manufacturers and companies who have gone either entirely renewable or partly renewable. One example is that both of Australia's steel makers, BlueScope and Liberty One Steel, are going into renewables. Liberty One Steel, particularly enthusiastically, they've got plans for 1 gigawatt of solar and storage to run their steel plants across Australia. So we've got the natural resources. The economics have changed to make renewable electricity viable. We're still left with the question of how you actually convert that electricity into heat, or how you use it to produce the things we want. And it's not a simple answer. The answer is what most of our more than 100-page report is dedicated to, just because there's so many different processes. But we focus on 4 different technology types. One is heat pumps. So I'm guessing probably everyone in the room is familiar with heat pumps and why they're such a incredible technology, which is their efficiency, which is several hundred%. So people are probably most familiar with heat pumps as a reverse cycle air conditioner. Now there are industrial heat pumps available which can produce hot water, hot air, steam up to 160 degrees in temperature. And what's really exciting about the availability of heat pumps with that kind of temperature ability is that if you walk into an average factory, the way it gets heat is with a centralized gas boiler system. Centralized gas boiler, and then pipes going out to all the things in the factory that need steam or hot water. That's really inefficient. Often less than 50% efficient. You're losing a lot of energy through those pipes. With heat pumps that can produce 160 degrees, you can start to think about entirely replacing that gas boiler system, and replacing a system which could be less than 50% efficient with a system that's several 100% efficient. And there are obviously cost savings that come along with that. In our report, we apply all these technologies to different industries. So for heat pumps, when I say we apply it, we have sort of theoretical case studies that we call how-to guides, where we say, let's look at the manufacturing of beer is one example we have. So beer would normally use a gas boiler, and we show how you could replace that gas boiler with heat pumps and what that would do to energy use and then costs. So heat pumps are a really important part of the electrification of industry, and there are many hundreds installed around the world, mostly in Europe and Japan, South Korea, very few in Australia at the moment. Next category that we looked at was a range of technologies categorized under, they all use the electromagnetic spectrum to produce heat. So the main ones are here, infrared, induction, microwaves, and radio frequency. So infrared is really good at heating flat surfaces or drying things very, very quickly. Induction, which is the same technology that you get in induction stoves, but what it's really good for in an industrial setting is heat treating and melting metals very efficiently. And microwaves and radio frequency are good for bulk heating of material that doesn't conduct heat very well. So something like cardboard or timber. We've got a case study where we talk about microwave assisted firing of bricks. Why that's interesting is that you can halve the energy use in firing of bricks and more than double the production speed by using microwaves. These are all really efficient technologies because what they have in common is that they directly heat a material. So if you think of using a microwave, it's only the food in the middle, maybe the plate or the bowl, the bit that gets hot, but not the air around it or the microwave itself. That's the source of efficiency. Whereas if you use a gas-fired oven, you're heating the oven, the air around it, and then finally the chicken or whatever you've got in the middle of the oven. And you're also having to set it to 200 degrees or something, whereas you only want to heat something to 70. So these avoid those losses of energy. They're really efficient. We also look at a whole range of electric furnaces. Industry uses loads of electric furnaces, kilns, ovens that are gas-fired. And just like you could replace a gas-fired oven at home with an electric oven, you could replace most of those with an electric furnace that just uses electrical resistance heating. Very simple form of electric heating. This also includes some specialized types of electric furnace, so electric glass melters, which tend to be gas-fired, but 100 years ago, before there was a lot of availability of natural gas, glass melting furnaces were electrically driven. So we could go back to that. They're a lot more efficient than the gas versions. That involves putting glass as a mixture of sand and things, which needs to be melted, and you put the electrical current directly through the sand. So it's electrical resistance, but the material is the resistance. Very efficient. Yeah, that's about 30% more efficient than using a gas-fired one. Yeah. And finally, we look at renewable hydrogen, which gets into our definition of an electrical heating technology because you use electrolysis to produce the hydrogen, so energy plus water, and you've got renewable hydrogen. And there's lots of discussion about hydrogen economy and what it's good for, but we focus at its use for that replacement of feedstocks that I mentioned. So you can use hydrogen to produce ammonia. We already produce hydrogen to produce ammonia, but we start with natural gas or coal. But you can remove the fossil fuel from ammonia production, and the same for steel production. So I mentioned 6 or 7% of world emissions. That's really because most steel production, not all, but most uses coal. A lot of it coal that originates in Australia. You can just as well make steel using hydrogen, and that's actually already been done commercially. You don't need to have a 20-year pilot project. It's already been proven.
Probably have some advantage using because the hydrogen would be a cleaner fuel compared with all the other things.
Yeah, that's right.
Whatever coal or gas.
Yeah, I'm actually just coming on to the advantages of electrifying, but one I haven't got up on there, but it is true, is that it's safer all around. For a lot of when you're switching from burning something to electrifying, you're getting rid of all the heat and the emissions and points of danger and ill health in a factory, noise as well. So the big advantage of electrifying is that we show you can often halve the energy required for a process. So because of the increase in the cost of gas and the falling cost of electricity, that means you can save costs by electrifying. Here's an example of what I mean. So here's the costs of gas and renewable electricity. Renewable electricity on the grid, where you're having to pay the network costs, which is significant in Australia, and here where you don't have to pay the network costs. These are based on our projections, which we explain in the report, from now to 2028. So you can see that already, if you can generate electricity on site, per unit of energy is comparable with what you're likely to be paying for gas for the foreseeable future. But this isn't actually the comparison that we want you to take home. This is the comparison. What's the cost of the energy service? Because you can often halve the energy input into the production of things by electrifying, and here we've used the example of melting a ton of aluminium using gas. Now, taking electricity from the grid is comparable with a wide range of gas prices. And if you can generate the electricity on site, it's cheaper than almost any price you're likely to be paying for gas. So the cost of the energy service becomes cheaper when you electrify. So another example, which I hinted at before when I was talking about bricks, is you often speed up the production process when you electrify. We've also got we've got quite a few examples of the speed. We've got one where we talk about using radio frequency to cure glues in engineered wood products. This is a process that takes hours in a gas kiln at the moment. I've been in touch with a Danish firm that sells equipment that does this in just a few minutes, so hours to a few minutes using radio frequency. Here are some heating times of gas versus infrared for heating thin bits of material to a certain temperature. So if you see the times are, it's several times quicker to heat it with infrared than it is with gas. So yeah, that's right. This speed advantage would probably, in many cases, that would be of more interest to manufacturers than even the efficiency advantage. You know, if we take the case of bricks, if you want to double production of bricks at the moment, you have to build another brick factory. But you could also do it by installing microwave assistants. A lot cheaper. So yeah, the speed, the control and precision, so you can control the temperature a lot better using electrical heating. This is why some processes already use electricity for heating, because of the control. You can precisely target it better. You can monitor it better. And this means that electrified heat processes are a better match for, if you've heard the term Industry 4.0, Industry 4.0, as far as I can tell, means the increased automation and digitization of industry. So electric heating processes are a better match for this, the new wave of industrial revolution. They're often smaller and modular, which means you can have smaller factories, and it also means you can install them sequentially. You don't have to do it all at once. So if we go back to our example of the centralized gas boiler, you don't have to replace the whole system with heat pumps on day one. You could replace a particularly inefficient part of the system with a heat pump and put the heat pump at the location where the heat is needed, and then over time replace your gas boiler. And as I think I mentioned, electricity can fire any industrial heat processes. There's effectively no temperature limit. There is a temperature limit when you're burning a fossil fuel. So gas burns at I think something like 1900 degrees, might be less than that. But with electrification, with a plasma furnace, for example, plasma torch, you could achieve 4,000 or 5,000 degrees centigrade. Hotter than you probably need for most things, but if you want it, it's there. So I mentioned at the end of the report, we apply these technologies to certain industries. So the production of pretty common materials. And certainly for these first 8, there are significant reductions in the energy input. The benefit of these is, I think there are small reductions of energy input, but the benefit is that you're moving from a very fossil fuel intensive process, where fossil fuel is a feedstock to the process, to using no fossil fuels at all. There's actually a renewable ammonia plant being built in the Pilbara at the moment. So one of the big uses for ammonia is in fertilizers, and the biggest fertilizer company in the world, I think, is a company called Whyalla, and they're building a renewable ammonia plant, taking advantage of the excellent renewable resources in the Pilbara. I'll just focus on one of these case studies, which is using induction for aluminium casting, because it really shows how, as well as those other benefits, sometimes by electrifying, you can rethink the way something is made to your advantage. So normally when you're making a complex product from aluminium, you need to melt it first. It goes through casting. So the way this is done is that several tons of aluminium is melted in a large furnace, and as you're casting each part, you just take off a little bit of that large amount of liquid aluminium. That's normally gas fired. You could replace that with an electrical crucible furnace, and you'd get straight away a 37% efficiency gain. But what induction allows you to do that gas fired doesn't, and this is what we focus on, is melt exactly the amount of metal you want when you want to cast the part. So you don't have to melt tons of aluminium at all. And the benefit from that is often 30% of the energy in a casting plant is just keeping the aluminium hot all day. Now, if you've got 20 tons of molten aluminium, you need a lot of energy just to keep it molten. With this, you just melt in a few minutes the few kilos that you need to melt the part. So we used as our inspiration Nissan Casting down in Dandenong, and they make parts for the Nissan Leaf. And they use this they have a huge crucible furnace. So you could just melt it part by part. If you did that, we called it single shot induction. That would be 50% more efficient than the process that they use down in Dandenong. There'd be less material waste because molten aluminium is really reactive with pretty much everything it comes into contact with, air and water and the sides of the vessel and things. Because it's molten only for a few seconds before it's cast, there's a lot more material waste, less wasted castings, etc. And it speeds up the whole process. So this is a really good example of how you can do something completely different by electrifying. So just to finish off, how do we make this happen? We hope we've shown, and that manufacturers will just seize the opportunity from what we've shown, the opportunity to speed up production and reduce costs. But we have to be realistic. There are huge barriers to doing this. And one of the big barriers is just a lack of knowledge about what we're talking about. I've spoken to many process and mechanical engineers over the last few months. Many of them don't even realize there are heat pumps that can produce temperatures above 100 degrees. So we're starting from a very low base. We're very far from there being lots of consultants being able to tell a factory, oh, you should install heat pumps and I'm going to design a system for you. And even if they knew, there's a huge vested interest in continuing with the gas boiler system. So to get over that, we're saying that government should develop industrial strategy. Industrial strategy isn't very popular, I don't think, in Australia, but other successful industrial countries, East Asian countries, Germany, do have industrial strategies. So there should be two aims of that strategy. One, to eliminate the emissions from Australian manufacturing, and two, not just to replace the industrial heat with electricity, but expand Australian manufacturing. So produce more ammonia, produce steel here using our iron ore resources and our energy resources, and create a lot more jobs in manufacturing. We also need to tackle the information deficit that I spoke about, increase the knowledge among engineers, manufacturers, consultants of the technologies we're talking about, offer financial incentives. One of the big barriers that I'm hearing so far in our limited engagement that we've had is that often, especially small firms, require a 2-year payback period on this type of investment. Sometimes, the things we're talking about can actually achieve that, but it's a pretty strict requirement to have. You're talking that requires you to have a 50% return on your investment, which is, I've never been offered a 50% return on my investment. Invest in research and commercialization. set sustainable procurement targets. So things like I mentioned IKEA, they've effectively set a sustainable procurement target. Many companies have. There's also an opportunity for governments to do this. And introduce a carbon price. At the moment, you're not even allowed to, exactly. You can't even say carbon price, but we're still saying carbon price. So the opportunity is to eliminate up to 8% of national emissions, increase international competitiveness, make Australia one of the homes of the production of energy-intensive goods and exports, and expand the manufacturing sector, driving innovation and creating high-quality jobs. So yeah, that's a very quick overview of our report. I'd love to take questions from you.
Did you find anything that you have to still need gas for, or that can't be currently finding another way replaceable?
No, there were some things that we didn't look at. Well, many things, to be honest, we didn't look into in detail. So probably the biggest one we didn't look at a lot was alumina production. So, that's the stage before making aluminium. You take the ore and you make alumina. It's actually a huge user of gas in Australia. There's only 4 places that make it. They use a heck of a lot of gas. But we looked into it enough to be reasonably confident that you could electrify it. Because, as I said, you can get any temperature. So you just have to throw enough electricity at it. Cement would be a difficult one because of the very high volumes at quite a high temperature. A cement kiln is nearly 1,500 degrees. But even there, it's possible. There's a Swedish company called Cementa who makes cement. Actually have a project looking at how to electrify cement kilns. And they won't quite tell me yet what they're looking at. But I think they're looking at both electrical resistance and plasma furnaces. Plastics, through oil refining, we didn't even try. We had an alternative strategy where we said, well, plastics, first of all, we should reduce the use of them. Then we should recycle a lot more. That's already done with electricity. And then any remaining plastics that we need should be bio-based. So I'm pretty confident to say you could electrify everything, but we didn't look into everything in detail.
No worries, thanks.
One thing concerns me
somewhat
is the sort of standard of knowledge around the place. For instance, there was an article in The Age yesterday which said that we're reaching peak as far as renewables are concerned. And there was a sort of a hand-wringing thing that, we've got to stop this. It's just so stupid.
They were saying peak as far as the system couldn't bear any more renewables. Yeah.
In which state?
Sorry?
In which state would that be? Because they're all different.
Yeah, I mean, obviously, wouldn't agree with that. Having an 100% renewable system wouldn't be that hard. You just need the storage.
I just have a vision of solar panels covering X square kilometers and generating hydrogen for export, for everything.
It wouldn't. If you did electrify industry, it would actually help. Obviously, one of the things you'd need, and where you're relying on variable renewables, you'd need much greater demand management than we have at the moment, and that's one of the things electrifying industry could do. So we produce a number of examples. For example, if you just had electric boilers, which you might have because they can produce higher temperatures than heat pumps, you could just turn them off for an hour if you were required to, and make money from that. They don't lose, they're well insulated, they don't lose much temperature in an hour. It's the same with if you had a large electric crucible furnace holding metal. You can turn them off for several hours. The temperature drops a bit, but as long as it stays molten, that's okay. We also talk about storing electricity as heat. So I don't know if people have heard of a firm called 1414. A few nods. So they're Adelaide-based firm. They're using silicon, and they use molten silicon to store heat. So they put excess. The idea is that you put excess electricity when it's very cheap at times when the wind's blowing a lot through the molten silicon, and then store and reuse that as heat. So that can be used as a type of demand management. So if we did electrify industry, it would actually help bolster the grid.
The other thing I'm interested in is hydrogen for transport. I think we need to really push on with that.
Yeah, well, that's probably another conversation. Yeah.
You mentioned.
Sorry,
Sorry about that. You mentioned the two steel manufacturers using electricity, but I'm interested in the Gupta business in Whyalla.
Yeah.
And the only knowledge of that is limited to the TV program about it, but it interested me that it appeared to be a solar farm with just conventional PV arrays, sort of stretching to the horizon.
Yeah.
I know it's not sort of the core sort of part of your discussion here, but I'm interested in the comparison with that conventional technology, and he's talking about huge increasing the capacity of the steel plant there by a factor of 10.
Yeah.
Compared to the mirror array with the salt column and that kind of technology and the molten silicon sort of approach.
Yeah.
Have you looked at the means of generation, or just accepting the fact that renewable energy is available in one form or another? Yeah,
we didn't look at a lot of the means of generation. That would have meant rewriting our first report, our stationary energy plan, and we didn't want to do that because it would have made it twice as big. Yeah, I think Sanjeev Gupta at Liberty One Steel is planning to back up the PV generation with pumped hydro. Right. So I think he's taken the decision that overall PV, because it's so cheap, plus pumped hydro is cheaper than concentrated solar thermal. But I think concentrated solar thermal has it complements what we're talking about here. For some people, one example is alumina production. So the first stage of alumina production requires lowish temperatures, maybe 200 degrees or something like that. That is a good example, and also because of the location of it, out in the middle of nowhere in Western Australia, of where concentrated solar could produce the steam. I'll just add another thing about what they're doing at Liberty One Steel. I was having a conversation with someone about this before the talk. Then they're replacing their existing electricity use with renewables, but they're still burning coal to make their virgin steel. They're still using a blast furnace. That's never written in the article, so they're not going to be 100% renewable by any means. They will be at their where they recycle steel in electric arc furnaces, but electric arc furnaces can't make virgin steel. Yeah.
Thank you. My interest is in the iron ore. It's a huge volume export. Yeah. And since we ship out huge volumes of material for transformation elsewhere, any saving that would be able to be achieved in transportation through actually doing the initial stages of transformation of the raw materials in Australia would be significant, I guess. And my question is there a research or a possibility or a likelihood that we might one day see iron ore in Australia being transformed into the early stages of iron production locally and then shipped in much smaller containers to our markets?
The early stages being conversion into steel,
extracting the iron from the ore. Yeah.
Yeah. On the first one, I don't know exactly what transport contributes to the emissions from steel production, but my guess is it's a very, very small part of it. When you look at products, transport is actually smaller than people expect. But for the second question, that's exactly what we're talking about. We're saying that steel is a very emissions intensive product, 6 to 7% of world emissions. So we need to make it another way. There's no better country in the world to make zero emission steel than Australia, because we've got the largest iron ore reserves in the world and the best ability to produce renewable energy. So if you make it with the hydrogen route, we should be making the steel here and not shipping any iron ore, and shipping steel.
First, just checking if I know the background to this. The first stage in making steel, you're basically taking off the oxygen
Yeah.
by putting carbon into it. So carbon and oxygen get together and they leave. So it's reducing the iron oxide to basically to iron.
That's right. Yeah.
Okay.
That's right. So when you do it with hydrogen, it's the same thing. So instead of iron, instead of ending up with iron plus carbon dioxide, it's iron plus water. Yeah. I mean, the difference is you don't have any carbon in the resulting iron, which you do need a little bit. So you have to add that at the next stage, which is in an electric arc furnace. But that's no big deal. In ordinary steel production, you have to remove a lot of the carbon, which is just as difficult. Yeah. Yeah.
Hi. Question about the capacity of our networks to deliver this increased electricity for industry,
Yeah.
and the cost of any increasing of the capacity.
Yeah, there obviously would be a cost. There would be a requirement to strengthen the networks because we're talking about an increase in electricity use for the country. But again, we didn't redesign the whole electricity system because that would have been a whole other report. I think we're confident that we could do it. You know, we've got networks at the moment that feed aluminium smelters of 500 megawatts and above. You know, you don't really get any machines that are more powerful than that, and we've managed to do it. So, yeah, it's just a question of the will. I think there's no technical hurdles to it.
Can you make some comments about the reliability of renewables? I mean, the politicians have a real time to depress the advantage of renewables based on the continuation of energy.
Yeah.
You know, particularly the South Australian.
Yeah.
situation.
Yeah. There are a few politicians that are obsessed with the reliability of renewables.
Yeah,
they seem to think they're the only ones that have thought about the fact that, you know, the sun doesn't always shine and the wind doesn't always blow. Obviously, yeah, it's a different system, isn't it? When you're using variable renewables, that it poses different challenges. But having coal-fired generation that you can't really turn off very easily poses challenges. I often think of a quote from the guy who runs the head of the national grid in the UK. So he was interviewed on the day when the UK for the first time got more than 50% of its electricity from renewables. It's a sunny, windy day. And they said, well, isn't it a lot harder to run a grid with this amount of renewables in it? And he said, no, it's not harder. It's just different challenges. It's just different. We'll need storage and demand management, but you know, we know how to do it. Sorry, I've got a question there.
What is the political and or bureaucratic will to support electrifying industry as a general concept? I mean, we have an awful lot of different messages coming out about that.
We're finding that out at the moment. We're just starting to talk to politicians about it. I think, to be honest, they haven't really thought about it. You know, I noticed when I was doing this research, just telling people about what they were doing, I had to work at explaining what energy I was talking about and what emissions. They were saying, oh, well, you're just talking about solar panels and wind farms. I was saying, yeah, but that won't do it on its own because these emissions are in the factory. And this is people who I thought would have understood that. Whereas, you know, politicians who have to be generalists, I don't think they've started thinking about it, which is surprising in a way because, you know, Victoria's got a legislated target for zero emissions, so that includes these emissions. But we're going to do our best to educate them. I noticed Pat Conroy, who's in the Labour Party, I can't remember his position at the moment, but he wrote an article recently essentially saying Australia was a renewable energy superpower, and we should, a lot of the messages we've had over the years, that we should use that to attract industry here, to export energy intensive goods. He didn't go quite as far as saying change the way we make things, but I thought that was encouraging that it was a senior politician thinking along the right lines. Yeah.
Yeah, I think, sort of going back to the earlier comment, the whole problem with any part of this question of renewables and global, climate change, global warming, whatever, is the preparedness of politicians to put political ideology before scientific fact. And I mean, the real information coming out of South Australia is that the use of renewables combined with the battery has improved their network performance enormously, and they can manage the network far better now because the response times are in sort of microseconds or nanoseconds instead of minutes and hours like it was before.
Only a battery
and yet it's still, every time the question of renewables comes up, the same old line is trotted out by the conservative politicians. The South Australian experience, and it's. I mean, I don't know what I haven't been a member of the ATA long enough to know whether there's a policy of staying out of politics, but maybe it's time to actually tell people, to suggest to people how they should vote in order to, because that's really going to be the only way to show them.
Well, well, Beyond Zero Emissions also tries to stay out of politics. I mean, one of the reasons is that if you become political, you jeopardise your position as a charity. But yeah, I think it's going to become harder and harder not just to opt out of having a climate policy for some of the reasons that I mentioned. If the EU, which is the second or third biggest economy, is saying to Australia, well, we may not sign a trade deal with you unless you have some climate policy. If things like that are starting to happen, it's going to be harder. Australia can't forever just be, out on a limb with virtually no climate policy, I don't think. And it's going to become harder and harder to argue that renewables are expensive. It's all right, it's ridiculous today, but in 10 years' time, solar could be half the price that it is today. I mean, at some point, it's going to become impossible to make that case, right? Yeah.
Can you just recap what happened in South Australia? They had a blackout, didn't they?
They had a storm, some pylons were knocked down, and politicians blamed it on wind farms.
And they fixed that by putting in a huge battery.
Well, other people can explain this, but they've achieved the balancing of their grid partly with this huge battery. So they've got a 100 megawatt battery now that when they have little peaks in energy demand, the battery just responds in 0.2 of a second or something like that. Does anyone want to enlarge on that?
The wind farm, they weren't all set to the same consistent and suitable fault ride-through settings. So they were just a hodgepodge. They were told to have fault ride-through settings, but in other words, they were set whatever they felt like the manufacturer was comfortable with. So they weren't set to as much as what could have been safely in other countries. So they started dropping out after about 30 lightning strikes in a minute or something like that. And that happened about the same time the towers were tipping over.
But it wasn't actually a fault in the wind farms, right? It was nothing to do with it.
Set to be to ignore faults as much as what they potentially could. Because the manufacturers just gave them a setting they thought would put them at low risk of getting damaged. The customer was happy with that. No one went, well, is that right setting? So it was all just
and that lesson's been learned, hasn't it? But politicians continue to say that it was because of renewable energy.
Just to comment on South Australia's prices, from the opennem.org webpage. Following that for 12 months or so, the peak price South Australia used to pay would sometimes get up to $2,500–3,000 per megawatt
hour.
Now it's down. It's a peaks of 200, 300 sometimes. And basically, it's the batteries just killed off the arbitrage that the gas-fired guys were paying.
So there's still a $14,000 cap on the market that's designed to stop it going even higher, but to still provide enough of an incentive for people to build PVs that might only run once every year.
South Australia in August, I haven't seen September figures, had the cheapest electricity in the nation. Which
really?
Hasn't got much publicity.
I hadn't heard that. That's great. That's great.
So, and the state that typically pays the state that pays the most seems to be New South Wales. Despite the fact that Victoria has shut down a gigawatt hour of coal, and in 12 months I think we've replaced something like 0.6 gigawatts with renewables.
Yeah.
So we've just about replaced it in 12 months.
Yeah. Yeah.
And it'll be fully replaced by the end of the year.
Yeah, it's great. And that's one of the things we say. Electrifying the whole of industry in terms of the generation wouldn't take very long. I mean, I think this year we're expected to build, including rooftop, 5 gigawatts of renewable energy, and that's with the federal policy we have. Imagine what we could do if every government was incentivizing the development of renewables. Yeah.
My question is about how we progress a bit more, and particularly in Victoria.
Yep.
What discussions are there with the Victorian government, and what particular areas can we promote actively?
We've got a meeting with the Minister of Industry's office in a couple of weeks. To be honest, they're winding down into caretaker mode. So it's difficult at the moment, but certainly the Lily D'Ambrosio, Minister for Energy, and others are aware of what we've done. We're also talking to, one of our ideas to push this forward, because of the lack of knowledge, is to develop a centre of excellence where manufacturers can go and test these technologies. So where they can go and test infrared and microwaves and things on their processes. So we're talking to ARENA, and we're hoping to get Monash University involved in a project to put significant funding behind a centre of excellence where knowledge of these technologies can be increased. We developed this report with the support of the Southeast Melbourne Manufacturers Alliance that represent 200 or 300 manufacturers are in the southeast of Melbourne, which is Victoria's big manufacturing base. So that they would be part of it as well. So that's one of our ideas to push things forward.
Can we get some publicity on the successes?
We'll definitely publicise any successes we have. Yeah, it takes time. With our last report, it took probably about 6 months for it to get ahead of steam. 6 months of going around talking about it before there was real excitement and things started to happen. I'm hoping it would be quicker this time, but it did take a bit of time.
You're referring to the cement
report, yeah.
So
yeah.
Actually got a couple of minutes. What has been the developments on the cement one?
Oh, okay, yeah. So the first good thing that happened with the cement report, so just briefly, cement produces a lot of emissions, and it's one of those sectors that if it's ever mentioned at all, you often hear, oh, you can't do anything about cement emissions. We're just stuck with those. So we wanted to show that wasn't true. The first thing that happened was the Infrastructure Sustainability Council of Australia introduced an innovation based on our strategies. So this council called ISCA, they're like Green Star for infrastructure projects like railways and roads. And in some states, any significant project has to have one of these ratings. And Melbourne Metro will have an ISCA rating, and the development at Melbourne Airport. So that they're becoming increasingly common. And so they now have incentives built into that rating to use the low carbon cement and the other alternatives we're talking about to reduce emissions from cement. That was the first sort of win we had. The second one was that Transurban, who build and operate motorways in Australia and the US, not usually associated with sustainability, came to us and said, we've read your report. They've signed up to the Science-Based Targets initiative, or they're going to. to reduce emissions. We want to reduce the emissions from the cement that we use, which is significant. Will you work with us and write another report that shows us how we can make serious reductions in the emissions from our cement, which is exactly the kind of thing we wanted to happen. Because, you know, if we talk to the cement industry and say you could do all these things, that, you know, they don't care. We're just a small charity. But if you're Transurban and you buy millions of tons of cement, then they start to listen. So that's been another of the wins. We've also managed to set up a Victorian working group on achieving the strategies in rethinking cement. So the working group includes members of government, people from the cement industry, people from construction firms and engineering consultancies. And we had the first meeting a couple of weeks ago, and we're working out, well, how do we get movement in this sector, because it requires more than one. You know, Transurban can do a lot, but it actually requires a number of different actors to move. Yeah, so thanks for that opportunity to talk about those. So hopefully we'll see something similar with this. Yeah. Just a quick question. Yeah, nearly all, I'm not sure how the ATA is funded actually, but nearly all just ordinary people. So if anyone would like to donate to Beyond Zero Emissions, this is how we survive. So some people give money, normally smaller amounts every month. I think that accounts for about 1/3 of our income. And then if we do a project like this, we have some philanthropists and philanthropic groups we can go to and sort of pitch to them, and they might give us some money. But we're not talking about huge amounts. We're a pretty tight ship. Until recently, there were only 3 of us there. We've grown a bit, now there's 5. So when we produce a report like this, I'm a paid researcher, but everybody else is a volunteer. So lots of students, people mid-career, retired people help with the research on a report like this.
And do you have any books available for sale tonight?
I've only bought 2. So there's 2 tonight. It's free to download. They're $35 if you buy them. It's not cheap, I know, but they're not cheap to print and produce. If there's demand for more than 2, you could always pop into our office in Flinders Lane during the week in Ross House, and we'd be happy to. It's very near Flinders Street Station, so it's quite convenient if you're ever in the CBD.
Is it possible to buy?
You can't at the moment. Our shop is, we're kind of in the process of changing websites, so at the moment you can't buy them online, unfortunately.
Yeah, look, I am pretty ignorant about this, and I'm just wondering if you could possibly, I don't know, go back like 40 years. You know, when I came to this country, I was working at Newport Power Station, building the gas-fired boiler.
Yeah.
You know? And they were saying that, look, you know, that all electric homes would be a sin. You know that.
Yeah.
You know, you didn't need Newport Power Station if you used natural gas and got the heat directly. You know, so if you need heat, you need to use a source of fuel that can produce heat directly, rather than boiling water, turning turbines, making electricity, and then using that to heat the home.
Yeah.
But things have changed now, right?
Yeah, it's
all because of the renewable.
It was always seen as a crazy idea to turn electricity into heat, and one of the reasons was we had these centralized power stations, and they were just wasting loads of heat. So why would you burn gas in a power station when 50% of the heat is just wasted to produce electricity and then convert that into heat? That doesn't make any sense at all, and I agree with that. But yeah, things have changed now because we have these non-fuel methods of producing electricity, like renewables. Now we're worried about emissions, which 40 years ago we weren't, greenhouse gas emissions. And we have things like heat pumps in the home and in industry, which have these incredible efficiencies. I think 40 years ago, there were very few heat pumps.
I mean, in 40 years ago, the option was only nuclear, right? To use that as a source of heat, because crude oil and coal contains, they're sort of result of millions of years of decay and storage of sunshine, basically. And, and it was concentrated fuel, whereas the sunshine, it was very diluted.
Yeah.
Right, and you couldn't really get the same?
Yeah, it is diluted, but what matters is the economics of it, especially in a country like Australia where the land isn't really an issue. The space doesn't matter that it's,
Right, so we can cover
diffuse.
half the country.
Well, it doesn't even need to be half the country. It's actually only a very small bit of the country.
1% of the country, less than 1%.
Less than 1%. Okay, thank you.
Basically, that's the difference. That's a game changer.
Yeah.
I bought my first panel for $900. You know.
Yeah.
80-watt panel.
Yeah.
And it was prohibitively expensive.
Yeah,
you know?
yeah, it was. 40 years ago, it was about 100 times more expensive.
The PV panels.
PV panels, yeah. Cost per kilowatt and kilowatt hour, I think it was about 100 times more expensive. You guys probably know better than me, but yeah. Yeah.
So that's the change. Well,
on a domestic front,
the
domestic heat pumps seem to be more efficient than, say, a solar panel to produce hot water. But we have a situation where we've had a solar panel for hot water for some years.
Yeah.
Which burst in the recent frosts. And the quotation to replace it, the suggestion is we put in a heat pump, and instead of about $1,000 or a bit more to replace the panel, we quote it's $3,000 to $4,000 to put in a heat pump.
Yeah.
Why would that be?
Why was that the recommendation?
Well, the recommendation came from the plumber.
Yeah. So replacing solar hot water, the recommendation was to replace solar hot water with solar panel plus heat pump.
Well, no, to not have a solar panel, to have the heat pump going into a storage tank.
So where's the electricity coming? Where's the electricity coming from?
Replace that too.
Where's the electricity coming from?
Well, at the moment, the water's being heated by a gas booster, which only comes on if the water out of the storage tank isn't hot enough. So at the moment, all the heating's coming from the gas booster because
this has got a bit complex for me. It's got a bit complex, but yeah. But look, it's a bit out of my area of expertise. But if we just stick to solar hot water versus heat pumps, as far as I know, in our buildings plan, we say there's a line across Australia. If you're south of the line, it makes more sense to have a water heat pump, a hot water heat pump, driven by a solar panel. If you're north of it, we're obviously south. The lines are on about Byron Bay. If you're north, it makes more sense to have solar hot water. But people in the room probably know more about this than me. Yeah.
There are advantages from the grid point of view. If solar hot water, if hot water is a significant part of the grid demand,
yes,
then the heat pump is standard across the year.
Yes.
And the demand for electricity tends to be peaking in winter, which is when you have less solar hot water produced. So from a grid point of view, actually the heat pump is preferred to the solar cells, solar hot water.
Yeah, yeah. Oh,
but
thanks for that.
That's from a grid point of view rather than from a specific person point of view.
Yeah.
Well, when we got the solar panel for the hot water, heat pumps didn't seem to have been even heard of.
Yeah, right.
6 or 7 years ago.
Yeah.
We put on
They were rare.
solar panel.
Yeah.
Any more questions? Now, before I thank Michael, because when you thank somebody, everybody tends to run away, I'll just say a little bit about next month, which is